I understand. We'll deal with it in a minute. That's okay. All right. So we're just picking up where we had left off in section 2.3. So we wanted, or this example asks us to show that the absolute value of x is equal to 0. Can I do direct substitution with this? No. Why not? The direct substitution requires a polynomial function or rational function, which is not what we have here. It's an absolute value function. So what should I do? Well, we need to think all the way back to like our Algebra 1 course. And if you remember, the piecewise definition for an absolute value is this. That the absolute value of x is just x for non-negative numbers, and it would be negative of x if you have a negative number. So if I look here, I can use that to replace the absolute value of x with just x. And now that it's polynomial, I can do a direct substitution. Rita?
Yeah, did you know that was greater than 0?
Well, this is the definition of an absolute value function. This is something we should remember from like Algebra 1 class. And I know that's been a long time. That's why we're doing an example with an absolute value in it, because this is what you'd have to do every time an absolute value pops up. It's to like, you have to do a left-hand and right-hand limit with each piece. Okay. We're not necessarily going to be able to direct substitute it, because direct substitution doesn't work if you have an absolute value function rattling around in there. Okay. Yes. Yeah. So we're using this idea here to get to the limit as x approaches 0. And taken together, I can then say, since the left-hand limit and the right-hand limit are both 0, the big limit is 0. Sorry, people, I see people doing the head weave. If that's the case, just ask me and move it up, dude. No biggie.
So in order to prove it, we have to go through all the possibilities.
Well,
like x approaches 0,
I mean, in this case we did, because we don't have another tool to evaluate that limit. We couldn't use direct substitution because it wasn't a polynomial function or a rational function. We had to do something different. So I had to go back to, okay, well, what's the definition of an absolute value function? I wrote that down. And then I said, okay, well, I can use this to do the left-hand and right-hand limits. And if those are both the same thing, then I know the overall limit. Right? That's why I had to do it this way. It doesn't necessarily mean if we have to prove it, we have to do it this way. But in this case, because of the absolute value function, this was what we had to do because we didn't have another tool to use. If it was a polynomial function, you could use your limit laws, or you could use direct substitution. It would be okay. But we didn't have that. Does that?
Yes.
Okay. So same idea here, right? Here it says prove that the limit as x approaches 0 of absolute value x over x does not exist. So we're going to do the same thing, right? So that allows me to, if I'm approaching from the right, I can replace x with just, or absolute value x with just x. And that just is 1. Hopefully everybody can see that. Maybe let's not. So those can reduce to 1, and then the limit of a constant is just a constant. Maybe I'll say it that way. Up. Why wouldn't I what?
Why would you just throw the zeros?
Because I'd end up with 0 over 0, which is indeterminate. I can't say anything about my limit in that case, right? I just reduced, right? X divided by x is 1. Okay, two people kind of mumbled something at the same time, and I missed what either one of us said.
I said, how did you take it out of the absolute value? That's what I was.
Okay, so because I looked at the limit from the right, I know that my definition of the absolute value is if the x is greater than or equal to 0, it's just x. So because I changed my limit going from the right and to the left, it allows me to dump the absolute value symbol, which is what I'm trying to do. Does that feel okay? Okay. So again, I'm using that definition because I'm going to, again, go from the left and from the right. Oops. So here, because I'm approaching from the left, I'm looking at values that are less than 0. I can replace the absolute value x this time with negative x. So negative x over x reduces to negative 1. And since the left-hand limit and the right-hand limit don't agree, this limit does not exist. Does everybody feel okay there? Okay. Let's do another. Oops. So here we're given f of x defined as a piecewise function. Am I going to be able to use direct substitution on this if it's piecewise?
No.
No. In particular, notice that we're not even defined at f of 4, right? Because the piecewise is for x is greater than 4 and for x is less than 4. If I tried to even plug f of 4 in, it's undefined, period. So that's should also tell me that direct substitution is no bueno there, right? What am I going to do? The exact same thing that I did above. I'm going to look at the limit as x approaches 4 from the left of f of x, and the limit as x approaches 4 from the right of f of x. Everybody's okay there? So if I'm approaching from the left, I'm going to use that definition for my f of x, because that's the 4s. That's what we do if x is less than 4. And now that I can do direct substitution with. If I look at my right-hand limit, I can replace the f of x with the square root of x plus 4, because that's what I do when x is greater than 4. Here, my limit law allows me to push the limit sign underneath the radical. So then I can use direct substitution. I'll write it. Since I know the limit is of a polynomial, I get 0 again. So what would I say then? Yeah. Yes. The limit would be 0 because the left-hand limit and the right-hand limit are equal. Is this feeling okay, Isabel? Hey, guys, I can't hear, okay?
For this one, you just like solve it out, and then the other ones are more like just like version of the absolute.
So yeah, this one I didn't need to use any alternate definition because I already had a piecewise function that I can use to do the left-hand and right-hand limit with. Before I didn't have a piecewise function, I just had something with an absolute value in it. So what I did is I like rewrote that absolute value as a piecewise function so I could do a left-hand and right-hand limit with it. Does that?
Yeah.
Okay. Okay. Next idea, and this is a big one on the AP exam. Like, there's almost always going to be like some part of a free response question involving the squeeze theorem. So this is one that you'd want to for sure have memorized. So first things first, we can say that if f of x is less than or equal to g of x, where x is near a, and the limits of both of those two functions exist as x approaches a, then the limit of the lower function has to be less than or equal to the limit of the upper function, right? So how does that help us? Well, if there's a function whose limit is particularly hard to take, if I can bound it by an upper function and a lower function whose limits are easy to take, I then can potentially find the limit of that inner function. So this says if f of x is less than or equal to g of x, which is less than or equal to h of x, and that doesn't have to be everywhere, it just has to be when x is near a, and the limit of the lower bounding function, that's the f of x, is equal to the limit of the upper bounded function, that's the h of x, that tells us that the function in between also has that same limit. So in the nice case, you'll get an f of x and an h of x for us, where it'll say, okay, like something is less than or equal to f of x, which is less than or equal to something. Find the limit as x approaches a of the middle. And all you have to do is take the limits of the outers and you're done, right? The hard situation is the example that I'm giving here, where all we're asked to do is take the limit of this thing, and we're not given an upper bound or a lower bound for our function. Right, so we're going to have to cook up our own f of x and h of x, where in the squeeze theorem language, our g of x, the function we're looking to take the limit of, is that. Certainly. Now, real quick, if I try to do direct substitution on this, I get all kinds of problems, right? I get sine of undefined, and like, what the heck does that? Sine's never undefined. Like, what does it? It's a mess. What the heck do I do with this? Right? So what we're going to do is we want to cook up a function f of x and another function h of x, where I can say that f of x is less than or equal to g of x is less than or equal to h of x, with the further condition that the limit of f of x and g of x, I'm sorry, f of x and h of x are going to be easy to take as x approaches 0. We need to come up with our own f of x and our own h of x. This is the worst case scenario with the squeeze theorem problem, is where you're not given the f of x and the h of x. You have to come up with them yourself. Well, when you can't do anything here, right? If it says show that this limit is something, and if you try like, well, there's nothing algebraic I can do with this, right? Like there's no simplification, there's no multiply by conjugate, there's no common denominators, there's no like trick I can use to evaluate this. It just looks like I'm stuck, right? Oh yeah, yeah. Often it would be a pain to use at any time, unless it's like
if you're stuck all the time.
Sure, you could try to use it. Sometimes it'll be more difficult than others. This problem is tailor-made for us to be a squeeze theorem problem because the f of x and h of x in this case are actually rather easy to come up with. So when I look at this, when I look at the g of x, I see two parts to it. I see an x squared, and I see a sine of 1 over x. Everybody agree with that? Let's think about the graph of x squared. Is that graph bounded in either direction? It's certainly not bounded above, right? It's going up forever to infinity. How about the graph of sine x? Is that graph bounded? Yes, right? It's bounded by y equals -1 and y equals +1. It's never going to get higher than those values. Everybody agree with that? That's the observation that I want to make. That's going to be what allows me to get my f of x and g of x rather easily. So what is the smallest possible value to come out of sine x? -1. Everybody agree with that? So my f of x, I'm just going to be -1 times x squared. Because that's the smallest value that sine of 1 over x could take is -1. That'll work. Elena, you're making a face.
Oh no, I was just one. No.
Okay. What am I going to pick for h of x then?
1 times x squared.
1 times x squared. So let's just kind of confirm this on our calculator, that if I look at the graph of -x squared and then x squared times, well, because here's the thing, Elena, is that the outputs of sine x and the outputs of sine 1 over x, the biggest and smallest output you can have is still the same because it's just coming out of sine, right? Like if I do sine of 1 over x, the biggest number that come out of it is 1, and the smallest number that can come out is -1 because I'm just taking sine of a number.
So will it always be like that with sine?
Could be always like that with sine and also with cosine, right? Because that's also bounded between 1 and -1. Sure. So if I do this, yeah, that'll be okay. So here I'm going to graph, there's -x squared. Here is x squared sine of 1 over x. And there's +x squared. And it does look like those two functions bound that other one, right? You guys buy that? Okay. So what does that allow me to do? It says the limit as x approaches 0 of -x squared should equal the limit. Well, that is just 0, right? Because it's polynomial, I can do direct substitution on that. And I have the limit as x approaches 0 of +x squared also 0, just direct substitution. I can say, now, by the squeeze theorem, the limit as x approaches 0 of, I'm just going to write g of x to save myself some time, is also 0. That's kind of the worst case scenario version that Michelle, or I'm sorry, Isabel.
Do we just get rid of this side, like the side whatever x is?
So if you have a sine or cosine,
Then you can replace it with
yes, with a -1 or a +1. Doesn't matter what else is inside the sine or cosine, because sine of anything is always going to be between -1 and +1. Cosine of anything is always going to be between -1 and +1.
Is there ever going to be a scenario where
I mean, probably not in this class, but I'd have to think on it. Yeah.
Is that like by the squeeze theorem and then the limit of x approaches 0? That's your answer.
Well, it says prove or show that. So that's like this, all of this is my answer, right? This is, I need all of it. That's me showing it. Like I've set up the conditions for the squeeze theorem,
Yeah.
and then I use the squeeze theorem to say, okay, that's my answer.
Do you ever have to go past that point, like solve anything else, or
Probably not.
okay? So you just,
This was the solving part right here, was when I did those two limits,
oh, okay.
right? They're just like really easy limits to do,
Okay.
which is good. When I set up my squeeze theorem, I want to pick f of x and h of x's so that the limits are really easy to take. What's up, Elena?
I understand how like f of h of x are 0,
Mhm.
but why does this squeeze theorem say that we can just start substituting in 0?
So what we're saying here is, since f of x is always smaller than or equal to g of x, and because h of x is always bigger than or equal to g of x, if their limits are the same, and that thing has to go through the middle, it also has to have the same limit, right? Like you have like this thing doing this, you have this thing doing this, and this thing has to come through the middle. If those two limits of the upper and lower are the same, the thing that goes through the middle has to be the same, because it has to be less than or equal to the top and greater than or equal to the bottom. If the top and bottom are the same number, what goes through the middle has to also be the same number.
Okay.
That's what it's saying. Does that?
Yes, that makes sense.
Okay. Very good. Braden.
How will we find the bounds if we're not using like sine or cos? Yeah, we're not using sine.
Well, it's harder then, right? Like, and kind of gets a little bit beyond the scope of what would be effective to use the squeeze theorem to do. So the squeeze theorem is particularly well suited if you have something with a trig attached to it, particularly a sine or cosine.
Yeah.
Like it's really well suited to that because you can do the trick that we've just seen. Now, the other way that we can do this is I can just give you like the f of x, the h of x, and just say g of x is just g of x and it's in the middle.
Yeah.
And I ask you to do like, find the limit as g of x approaches 7 or something. So you just do the limit as f of x approaches 7, and the limit of h of x approaches 7 to show that they're the same. And that would get you g of x. That's the other way we can ask the question, is where I don't give you the g of x, but I give you the upper and lower. There, the limits are usually harder to take. Here, the limits usually end up being easy because there's only so much we can. Actually, finding the bounds for this is, like bounding functions, is not easy in most cases. Isabel.
You said that this is like an example of one of like the worst case scenarios. Can we do one where it's like just like a normal kind of scenario?
Well, the other here. So there's kind of two versions of this question, right? Oops. Where's my zoomers? Okay, so, oh gosh darn it. Stupid thing. So, Isabel, if you look at 37, like this is the example, or in 38, this is an example of the other way we can ask this question, where we've given you the string of inequalities, right? Here's your f of x, here's your h of x, and we're just asked to find the limit of the middle function as x approaches 4. So I just need to do the limits of the end and show that they're the same. And that'll,
Where's the h of x? How do you
it doesn't, okay, so the names don't matter, right? You have a lower bound, a function that's the lower bound, and you have a function that's an upper bound, and you have something stuck in the middle. Whatever they want to call the letters, it's like arbitrary, right? It's like me saying the first letter of the alphabet has to be A, but I could have just as easily said B should be the first letter of the alphabet, and it should be B, C, D, E, and ends with A, right? Like it's still the same alphabet, right? Like it's just arbitrary the order that we've given it. Here it's like arbitrary the names that we're giving these things. So you just need a lower bounding function and upper bounding function, something stuck in the middle, which is what we're given in like 37 and 38 here, right? Right, lower bound, stuck in the middle, upper bound, right? So all you need to do is take the limit of the lower and the upper, and if they're the same, the middle has to be the same also. If they're not the same, you can't say anything about the middle. That's it. So I think this is easier because you don't actually have to create anything on your own. You just have to do the limits of the top and bottom and then say, by this, if they're the same, by the squeeze theorem, this limit is also that. Right? Is that okay? Okay. I did okay on that? I could tell everyone was seeming...
You're killing it.
Thank you.
Of course.
I'm trying, I try very hard to make this like
I honestly enjoy this class. Like,
simplify and yeah. Well, thank you.
I'm so serious.
37? I mean, so if I take the limit of this as it approaches 4, I can just do direct substitution and plug it in. So 16 minus 9 is 7. And I can do this one the same way. So 16 minus 16 plus 7 is also 7. Since those two limits are both 7, the limit of f of x as it approaches 4 is also 7 by the squeeze theorem.
I thought the top part was also.
Yeah, so no, 36 is a separate problem. Although would not be hard to, after what the example we've done, would not be hard to do 36, right? What's the lower bound going to be?
0.
Negative 1 times the square root of x cubed plus x squared. What's the upper bound going to be? 1 times square root of x cubed plus, yeah. And then you do the limit of each and you're done. Right? And it's easy.
Yeah.
You leave that number and try.
Ever might be.
No.
Might be a little bit.
It's just like negative 1. That's not negative 1. Oh, duh.
Does that feel okay?
Yeah.
Okay. All right.
Yeah. And the options only down 50%.
That's not his fault.
So what I want to do next, rather than start a new section given the short time period, and I know you guys probably still want to ask 2-3 questions. I want to show you this real quick. and then we'll do some 2-3 questions. Okay?
Yes.
All right. Yeah, we'll do 2-3 questions in just a second, but I have some other thing that I want to assign here. Okay.
Well, this set of homework's due this Sunday, correct?
Yeah. Yeah. So, you're welcome. So, what I've done here as some additional practice is on the My AP is I've assigned it's called a quiz because they're all called quizzes when I make them and assign them. It's not really a quiz grade. It's just like, this is just a homework assignment. What did I call this thing? I called it Chapter 1, Practice Number 1. And it's just like 10 I guess it's 11 multiple choice questions. So you can do them in the My AP site. It'll give you your grade as soon as you're done. You can take as long as you want to do it. You can think about it. You can talk to each other. It doesn't have to be done on your own. It's just to get you used to like practice doing some multiple choice math questions. All these questions I've selected can be done with no calculator. I'd encourage you to try doing them with no calculator, just as the practice for that. So it'll be, they're just like doing limits with graphs and tables and stuff. And then there's some like now getting into algebraic limits. But again, the algebraic limits, the worst case scenario is you're going to have like whole number multiplications and additions and subtractions, which is all something I know that you can do with no calculator. I know. But yeah, that's the gist of it. Okay with that? So you log into the My AP site, and if you go under your assignments or whatever, you should see it there. Okay.
So then,
It's an upcoming, because it opens at like an upcoming.
that's part of our homework.
Yeah. It doesn't have to be due by Sunday. We'll talk about it next class. So, what's up?
Never mind.
Is it Mr. Is
I literally, all I want you to do is practice. I don't care what the score is.
Oh, okay.
I don't care.
I was just wondering.
It's the, yeah, no, I understand. I know.
Is it or no?
I don't care about the accuracy.
Can you stop? He's
I'm-
trying to talk to me. Let him talk to me.
Shh.
Let him talk.
Okay?
He's a teacher. You're not.
I'm not grading. I would tell you if I'm going to grade something on accuracy before I assign it, right? Because that's important. It would differ the approach that we take. I just want you to try. Okay? Part of getting ready is just getting reps. We don't take a lot of multiple choice for math. It's a new kind of skill to practice. I just want you to practice it. Braden?
What is due this weekend? Is it 2.2 and 2.3?
Yeah, let's say 2.2 and 2.3. If you still have a little at 2.3 you need to finish, it's not the end of the world, right? Like, it'll be fine. I don't care. We can finish it next week or whatever. Okay? It's probably because I looked at the other schedule or whatever or something. I don't know.
Yeah, because I already finished the homework.
Let's
Yeah, but how did you do class 32?
You're doing it up here. Yeah. You would just take a picture and then go like everything. And just create a little path. I'm doing it in here, but you can just upload it.
Do you guys want to do any more questions from 2-3? We still have 10 minutes or so. Let's rip through a couple of student questions. Braden?
10. I didn't know what part of it.
Okay.
And then
Sure. 10.
Yeah, so that's what I mean, it's just host me use this step. Like, I
All right. So, what's wrong with the following equation? it looks like nothing, right, at first glance? Because you're like, okay, well, I factored that and I reduced, and that's what I get. This is the issue. That's true, except where, oops, x is equal to positive 2. Because on the left-hand side of the equation, positive 2 is undefined. On the right-hand side of the equation, positive 2 is 5. So those two equations are equal, or expressions are equal, except at positive 2. Because the left-hand side is undefined, the right-hand side is 5. So that's what you're missing there. Yes, because to do this, you need to be able to say that's true except at some value of a, which would be 2. So this was that, what was the theorem number? Oops. It was this one, right? So that part B is this theorem exactly, just with specific numbers, right? F of x is the rational function, g of x is the linear function, and x not equal to a is x not equal to 2, right? So that was the idea there. Prater, are you happy?
Yeah, and then I had a question about 2A. It was based on if that.
Yeah, let's grab that real
Showed
quick.
if that applied.
No, I would not say so because the functions aren't continuous or even defined at those values. So what I would say here is that 2a, I can use my limit laws to do this. Because you can always do that regardless of whether things are defined or not. If I do now the limit as x approaches 2 of f of x, I go to f of x, 2 is right here. So from the left and the right, they both approach 2, so that should just be 2. And g of x, as we approach 2, 2 is right here. So from the left and the right, they both go to 0. So that looks like 2.
Okay, that was confused on whether or not I was supposed to use the define point for the f of x or the one with the base.
So it's because you're using the limit. You can't do direct substitution because you don't know if these are polynomial or rational functions. This is just some arbitrary function. So you definitely can't do direct substitution. You have to look at the graph and use the limit from the graph. Does that feel good? Tessa?
Can we just add this one?
F?
Yeah.
Sure.
That was the one
Okay, well, let's just start. I'm going to first start by using my limit law that allows me to push the limit underneath the radical. And then I'll distribute my limit. And I know the limit of a constant is just a constant. The limit as x approaches 1 of f of x, if I go to f of x, 1 is right here. So the left hand and right hand limits both approach 1. So that's my limit there. And this 3 plus 1 is 4. Square root of 4 is 2. Tessa, you look confused by, you look like you're doing good, and then all of a sudden you're not. Where'd I lose you?
There's just a rule for that. You solve it.
Sometimes we just need a minute to sit and think. Sit and think.
I knew you said do the substitute the 1 into the x.
I did not do that. I went to the graph and I looked at where 1 is for x on f of x, and then I looked at the limit, right? So the left-hand limit and the right-hand limit both go to 1, which is also what f of 1 is. but I did not plug 1 in for f to do it. I did the limit. I did not evaluate f of x. It just happens that it evaluates the same thing as the limit. Is that okay, Tessa? You see the difference? You're going to think on that and get back to me? Okay, that's fine. You don't have to get it right now, but you understand what I'm saying right now? You need to think about it a little harder to make sure? Okay. If you still have problems, come back and talk to me. I know you will. Yeah, you're not shy. It's okay. I don't worry about you. If Tessa's confused, I'll know. No big deal. That's good. Yeah, no problem. Not tomorrow, though, because there's no CT tomorrow. Because we have assembly.
Wait, when's the pep rally?
I don't know. Prater. What?
We did it.
No, but we weren't here because we were second.
Yeah, just come by during a community time sometime and remind me that it's the 2-3 homework quiz, and I'll give you a problem to do. Doesn't have to be today. Yeah. Yeah. Yeah, if you guys missed the homework quiz.
We are being good citizens.
I know, it's fine. I'm not mad. Do I sound mad? No.
I just wanted to explain.
Yeah, it's okay. Rita.
Like I feel like Brady Phelan. Like should I cross check it with him now?
I'll remember.
Okay.
I'll remember. Yeah, I know. I realize what happened. It's okay. We're gonna do like a million of these, so it's not usually a big deal. It won't be a big deal by the end of it. Other 2-3 questions. Anybody else? 2-3 questions. Anybody else? Happy to do some more. Yeah, praise.
What was it? E and F.
1 E and F?
Yeah.
Okay.
Yeah, actually.
Okay. All right. So right away on E, I would look and say, okay, well, I probably want to do that quotient limit law. The problem is the limit of the denominator is 0. So I can't do anything here. It's literally like you just can't do anything with this. There's nothing to do. I can't say anything about it. Doesn't mean the limit doesn't exist. It might exist. I just can't get to whatever the limit is with the information I have. Okay? And then here on this one, I can, this should be fine. It'll just end up being 0. So I can do that. And then I can use my product limit law to break that product up. And now I can just substitute in. So g of x is -2, h of x is 0, f of x is 4. That just comes out to 0.
Because when I checked the answer key, it had the answers flipped, I'm pretty sure.
Oh, really?
Yeah,
Let's look. Yeah, that would be confusing.
For E, it was actually
Yeah. Mine, okay, so my answer says, no,
yeah, you're right.
Yeah.
It was very late long.
That's okay, man. Okay.
You're right. Yeah.
Okay. Yeah, no problem. It happens. I get it. Yeah, at least it makes sense now, right? Like, I'm okay making mistakes if at the end of the day I got it, right? just a stepping stone on the journey to understanding. Okay. Everybody relatively happy with where we're at right now?
Yeah.
Okay. So just looking ahead, we have like 2-4 is like we're gonna just talk about it for like 15 or 20 minutes. It's like a not a real section. I'm not gonna assign any homework from it. We're just gonna do a couple examples and just move on. It's beyond the scope of this course, but 2-5 and then 2-6 are real sections. That neither one of them I think are incredibly difficult. I think 2-3 is the worst section. And then we're gonna be looking at a test. So we have like 2 more real sections, and then we're going to do a test over what we've done so far.
Like before Labor Day or like after?
Probably it'll be after.
Okay.
So right now, tentatively, like the format, it's going to be like, I'm going to have a no calculator section with some multiple choice questions and like 1 regular free response question. And then like a calculator section now, although I don't think the calculator would help you tremendously. And then like, I think like 7 or so like regular kind of questions. Like just, they're all gonna be limits. That's basically all we've done. 1 question from each section is like a free response style AP question. But they're just like, because of what we've done so far is really limited. They're pretty narrow and specific. Oftentimes the hardest part about them is they can be very broad and drawn like things from like multiple different chapters, which makes them challenging. But that's kind of the format that I'm looking at right now. Braden?
So you were saying that the like test and all that 70% is 100%?
No, I was saying that I was saying that the way I wrote the semester exam last year, that was what I did because it mirrored what the AP grading is like. So there's like 100 points on the final, the semester final. You needed to get 70, or it was graded out of 70. So you do as much as you could. It was not designed for you to be able to finish. It was not designed for you to be able to do everything. Right? But again, I don't know if I'm going to do that again, but I was giving you an example of like, I would tell you in advance if there's going to be like an unusual grading where it's like, okay, I know I'm not supposed to feel good when this is done, and it should still be okay. I would tell you that in advance. What?
So we should block out feeling like you failed.
No. I don't know that we're going to do that for the midterm. I'm saying that's what the AP exam will feel like, though.
Oh, the AP exam's gonna be rough.
And it's okay. It should feel rough. Just don't give up. Don't quit. Just take a deep breath and slow down. And go carefully, do all the stuff you can. If you don't finish, you're doing fine. You should, not necessarily will you finish. Like, if you just collect as many points as you can. If you don't know how to do something, skip it and go to the next thing that you can do. You know, like, it's...
Whenever I do that, I end up just skipping the whole thing.
We're gonna try our best to be as well prepared as we possibly can. You know, like I think we're gonna be fine. You guys are working. You know, seems like you're working very hard and you're trying very hard to understand things, and that matters. Just as a reminder, guys, are you going to get any equations or anything from me ever? No. Again, the AP is real rough on this. You know what else they expect you to have? Is all of like the unit circle. You should be able to do unit circle stuff without a calculator. Like sine, cosine, tangent of like pi over 3 or 2 pi over 3 or 3 pi over 4. You should be able to do those things, as well as like your basic trig identities You should have those. Still, you should have your basic trig identities like tangent is sine over cosine. Sine squared plus cosine squared is equal to 1. You should still have all that in your head. They do expect you to have all of that. I know.
Can we go over that? Like,
Yeah, I mean, we might need to review this.
I can dump the sheets in again
okay, yeah, thank you.
with the unit circle and the basic identities on
You
it.
should play like unit circle mini games. Like at the beginning of class, just like help us like get back into it.
Well, we have so many things to do with it. We have the homework quiz at the start of every class also. Yeah, great question. Will there be a homework quiz next class? No, because we haven't done anything. We're just going to talk about the multiple choice questions. Sound good? Okay.
So I sold.
Hi.